Welcome to Learn, your gateway to knowledge. Must like, comment, and subscribe.
Subject: APAI, Application of Artificial Intelligence, according to the syllabus provided by WBCHSE, Semester 4, Part 1. Must like, comment, and subscribe. Introduction. In this unit, we will learn about AI for medical and healthcare. Must like, comment, and subscribe. AI for medical disease detection. For example, diabetes detection. We already know K nearest neighbor algorithm. In here we use this algorithm to detect diabetes. KNN algorithm. Here are inputs are age, BMI, glucose level, insulin, etc. KNN compares the new patient's data with stored patient data. The majority class among the k nearest neighbors decides the results. Suppose a new patient has glucose level 150, BMI 30. We want to check if they are diabetic or not. We compare with 3 existing patients here, that is k equal to 3. Here is the table. Students given a patient, there are 3 patients A, B, C. The table showing glucose level, BMI, and diabetes probability data. Step 1, calculate diabetes. Here we use two features, that is glucose and BMI. We use simple Euclidean distance formula, already it is known to us. Here is the formula. Distance to A is root over 150 minus 160 whole square plus 30 minus 32 whole square, that is equal to almost 10.2, and also distance B equal to 51 and distance to C equal to, we find 5.4. Step 2, choose nearest 3 neighbors. Distance in order. Here is the table we already given. C 5.4, yes. 2 10.2, yes. These twos are closest distance. So according to the majority vote, yes equal to 2 and no equal to 1. That implies final prediction, the patient is diabetic. Now we use artificial neural network for diabetic detection. It works like the human brain with interconnected neurons, learns complex patients from data. Let ANN has inputs like previous problem, glucose, BMI, etc. Here one hidden neuron and one output neuron for diabetic probability. Given values, inputs already we know 150 and 30. Here hidden neuron nodes WH equal to 0.02 and 0.03 and bias equal to 1, and output neuron weight equal to 0.5 and bias equal to -5. Here we use activation function sigmoid 1 by 1 plus e to the power minus x. Calculate hidden neuron calculation. Z is equal to 0.02 into 150 plus 0.03 into 30 plus B. Here we used by weighted sum formula plus bias 1, and also the value equal to 4.9. Now activated function, which is sigmoid function. According to sigmoid function, value is 0.992. Now output neuron calculation. Here Z0 equal to 0.5 into previous activated value, that is 0.992 minus bias 5, which is equal to minus 4.504. Then output predicted activation value equal to, that is according to sigmoid function, 1 by 1 plus e to the power minus x. The value is 0.011, then percentage value equal to 1.1%. Chance of diabetes percentage. Here we saw the low percentage, that is the patient is non-diabetic. Students, we have now learned to determine the probability of various types of disease using two formula. I think you can do it. If this video helps even one person, I'll be more encouraged and will continue making more videos. If there are any unintentional mistakes, I'll gladly accept your valuable feedback. I'll try to provide various topic-based videos related to computers following the higher secondary syllabus in both Bengali and English. Best wishes to all students and heartfelt thanks to everyone else. Must like, comment and subscribe. You must like, comment and subscribe.